Hi, welcome back on creating table with constraints in SQL. Let's dive in. To start, we need to create a table in the database. The SQL create table statement is used for this purpose. So we are covering three constraints: not null, unique, and primary key. The not null constraint in SQL ensures that a column cannot be left blank. It's like making a field mandatory. Now we'll be working on MySql workbench where we are creating the database student, we'll use student. If you see, we are executing the commands and the action output is accepting it. Suppose that we are creating the table name person where we have the columns ID, first name, last name and age along with the data types. With the ID, first name, last name, we are using the not null constraints, and with age we are not.
Okay, so this is the common way to use the create table statement for each constraint.
Now we'll be using descriptive function to see each characteristics of a column of a table. If we wish we want to alter the particular column later, we can use the alter table function where we can modify. For example, here we are altering table person, modifying age integer, and we are using now not null to see how does that make a difference in a table. Next constraints we are picking up is the unique, which is essential for maintaining the data integrity and ensuring that the values in a column or combination of columns are unique. The unique constraint guarantees that each value in a specified column or a set of columns is distinct, which prevents duplicate entries, ensuring data accuracy and consistency. By enforcing uniqueness, the unique constraint helps maintain data distinctiveness. This is crucial for various applications such as preventing duplicate customer records or ensuring that each product has a unique identifier. Unique constraints are often used in a combination with primary key constraints to uniquely identify individual rows in a table. A primary key constraint ensures that a column or a set of columns contains unique value and cannot be null, which we'll discuss further with the primary key constraint. Let's explore how we'll apply the unique constraints in SQL. Let's create a table name person with the unique constraint on the ID column. We'll define a table with the columns ID, first name, last name and age. The unique ID clause ensures that the ID column must contain unique values, which prevents the duplicate records based on the ID. So now we'll insert some data into the table people where we are putting the first row has a ID 1 which is unique, the second row has a ID 2 which is also unique. See, when I am recording the third row, I have put the same ID 2 and changed the other columns Priya Sharma 40. I have changed the Riya Sharma to Priya Sharma and the age also changed, but the ID remains same 2. So now if you see the action output, it is throwing an error that duplicate entry 2 for key people ID is not allowed. Later when I am adding another record with the ID 4 Priya Sharma 40, the other columns data remains same but the ID from 2 to 4 is changed. See the action output, it is accepting that row. Later, if we wish to add the unique constraints to other columns as well, we can use it through alter table people. Add unique, this time I'm using the unique constraint to the first name. So along with the ID, now first name has also the unique constraints. So which means that we cannot use the same name and same ID to the following data. Now we are picking up the last constraint here, which is primary key. This fundamental constraint plays a crucial role in ensuring data integrity and efficient data management. A primary key constraint guarantees that each row in a table has a unique identifier. This identifier is essential for distinguishing individual records and maintaining data consistency. Primary keys are often used to establish relationships between tables. This allows to connect related data and perform efficient data retrieval and manipulation. For example, we might use a customer ID as a primary key to relate customer information to their orders. One of the benefits we use to get from primary key is that the database system automatically creates an index on the primary key column. This index improves the query performance by providing a faster way to locate specific rows based on the primary key value. A primary key constraint is unique and not null. which means that the column designated as the primary key must contain unique values and cannot be empty, which ensures the data integrity and prevents the inconsistencies. Now create a new table people1 with the ID, first name, last name columns along with the data types. Here I am using primary key with the ID column, then using the descriptive function to see how does that work. Later, if we wish to alter that, we have to use the primary key to another column. We can do that by alter table. We'll add the constraint primary key to the particular column name. But doing so, it is giving an error that multiple primary key denied, which means that we cannot use two primary keys in one particular table. Either we have to remove that table and create it one again. So in this case, I have done drop table and then we have created the table again using the composite primary key. So composite key means that we have seen we cannot use two primary keys together in a table, like we can use one and then altering to the another one. We cannot do that because it's throwing an error. So in that case, what we'll do is we'll use a composite primary key, which means that while creating the table, we'll create an index. Here in this case, the constant pk primary key ID and first name clause specifies that the combination of ID and first name columns will serve as the primary key. This means that each unique combination of ID and first name will be distinct within the table. The command will display the table structure including column names, data types and the primary key constraint. For instance, a large healthcare organization faced significant data integrity challenges within its patient database. We created patients table with columns for patient ID, first name, last name, social security number, date of birth and contact information. The primary constraint on patient ID ensures that each patient has a unique identifier, whereas the unique constraint on social security number prevents duplicate records. The not null constraints on various fields ensure that essential data is not missing. So how these constraints are benefiting here? They are preventing duplicate records, they reduces the risk of medical errors, they streamlines the billing, research and reporting processes, right? So by implementing all these constraints, a healthcare organization can significantly improve data quality and ensure the accuracy and reliability of the patient's information. I hope these three constraints are now clear.